Okay, so part C says, find a formula for S of n, the total number of matchsticks required to make the first n patterns. So it gives us a nice hint here when it says S of n, that we're using series, we're adding up each term. Whereas before we were using the T of n formula. So we can go to our log tables on page 22 and so we can write this formula down. So S of n is equal to n over 2 times 2a plus n minus 1 times d. Okay, so writing down that formula alone, we have 4 out of 10 marks for this question. Okay, then we need to figure out what our different letters are that we're filling in. So we know A is the number of matchsticks for our first pattern, so it was 3, and D is the difference, so every time it added on 4. Okay, so we're just going to fill that in. So I'm going to have n over 2 times 2 times 3 plus n minus 1 times d, which is 4. Okay, so when we go to do that out, so 2 times 3 is 6 plus, and then we have n times 4, which is 4n, and then minus 1 times 4, so minus 4. Okay, so we have n over 2 being multiplied by 2 plus 4n. So when we multiply that out, so n over 2 by 2 is just n, and then n over 2 by plus 4n is going to give me plus 2n squared. Okay, so my formula for S of n is, usually if there's one variable with a higher power, we might write that first, so 2n squared plus n. But if we did just stop there, that's perfect as well. Okay, and then C part 2 says, find the total number of complete patterns in the sequence that can be made using 820 matchsticks. Okay, so this is the number, S of n is the total number of matchsticks. So S of n here, the total number of matchsticks we've been given is 820. And we just came up with a formula of for what S of n is. So it's 2n squared plus n. Okay, so we need to figure out what value do we have for n in this situation. So when we have a formula like this, we can't really solve for n nicely. What we're used to seeing is like something and then the variable squared plus something and the variable plus something equals 0. So we want it to equal 0 here. So I want that 820 to equal 0. So I'm going to take 820 away. So I'll take it away from both sides, because if we take something away from the right, we have to take it away from the left. And I'll be left with 2n squared plus n minus 820 is equal to 0. So remember when we do something like this out as like factorizing quadratic, the variable that's squared, it doesn't have a coefficient of 1, it has a coefficient of 2 now. So we can't just do it the quick, simple way that we had done before. We need to multiply the coefficient of the squared variable by this constant. So I'm going to multiply 2 times the minus 820 and see that we need to be getting factor pairs for minus 1640. Okay, so that's what I'm going to be looking for things to multiply to get. And then of my factor pairs that I list out here, I'm going to be looking for things with a difference of 1. Okay, because there's such a small difference between them, I'm looking for something very close to the square root. Okay, so for example, if I had like 36 and I wanted a difference of 0, I'd be using 6 and 6. Okay, if I wanted the closest next numbers to the square root, I could use 4 and 9, and then the further away from the square root I go, the bigger the difference between the numbers. Okay, So here I want to use something really close to the square root. So I'm just going to type into my calculator square root of 1640, and I get 40.4969 blah de blah. So I'm going to see, is 40 a factor of this 1640. So I'm going to check, is 40 a factor of this? So 1640 divided by 40, and I see that 41 multiplies by 40 to give me 1640. So that's the factor pair that I'm going to use. Now they're multiplying to give me a minus, so one needs to be a plus, one needs to be a minus, and I want them to add to give me a plus 1. Okay, so they're adding to give me a plus 1 here, so it's going to be a minus 40 and a plus 41. So I'm going to change in my equation that plus 1n to being minus 40n plus 41n. Okay, so I'm going to rewrite out my equation. So unfortunately, this one isn't as nice where we can just open up brackets straight away. But we can replace the plus 1n with minus 40n plus 41n. And then factorize it using 4 terms. Okay, so our grouping method. Okay, so when I go to factorize this, so I'll factorize the first 2 terms together first. So my highest common factor between 2n squared and minus 40n is 2, and then I open up my brackets, 2n. And then I open up my brackets, and 2n multiplies by n to give me 2n squared, and it multiplies by minus 20 to give me minus 40n. And then for these two, my highest common factor is plus 41, and it multiplies by n to give me 41n, and it multiplies by minus 20 to give me minus 820. Okay, so that's equal to 0. Now I know I'm on the right track because my 2 brackets here and here are the same. So what I'm going to do is I'm going to open up brackets. I'll put what was in front of my brackets in one bracket, so 2n plus 41, and then I'll put the common bracket in the other. Where is this? Here. So I'll put the common bracket in the other, so n minus 20. Okay, so I'm either going to have 2n plus 41 is equal to 0, or n minus 20 is equal to 0. Now, I can't have a n value that is negative, okay, because it's like I can't have a negative number of patterns. So this value of n here, I can just straight away just say, no, that's not what I'm looking for. So it must be the value of n that I get over here, which I've run out of space, so I'll just go across, is n is equal to 20. Okay, so that's the value of n that I know I want to use. So I'm just going to put a box around that.